To find this slope, of course, we already know from the knowledge junior school, junior high, because this is 3, 4, so the slope will be, the equation will be 3x plus 4y, because this is a normal vector of this tangent line. 9, 16, 25. And for here, so the slope equals minus 305. 4, not 5. Here, the tangent equation of this tangent line will be 3x minus 4y, 9 minus 16. So here dy dx, the slope here is 3/4. Okay, let's find the slope by ordinary method. By chain rule, polynomial first, power second. Minus 2x. Therefore, exactly this one. And we notice this is exactly the original function. Okay, this is for the at this point. If we want to find the tangent to this circle at this point, 3 minus 4, we consider this function. This function is minus again, use the chain rule. 1/2 as the coefficient. We decrease the exponent by 1. Then times the derivative of an inner one. Minus and minus is positive. And the 2 and the 2 are cancelled. Therefore, y prime at x equals 3, this time equals 3 over see, exactly 3/4. Okay. Now is the time to is the show time to use the explicit differentiation, the implicit differentiation. Okay. Begin with this equation. Differentiate. Oh, when we have x squared plus y squared equals 25. Keep in mind y as a function of x. Keep this in mind because if we are given one value of x, we can solve maybe one y, another. So we treat y as a function of x, lowercase f, some function. So differentiate this. With respect to x, for any x is given, when x vary, then this will automatically keep this value, this constant. So the rate of change of the constant equals 0. But here, differentiate x with respect to x. This is 2x. But here you have to treat y as a function of x. So 2y, y prime. I mean, maybe I have better. This means 2x plus, use the generalized power rule, 2f of x times f prime x equals 0. So y prime equals minus 2x over 2y. This is exactly 2x minus and 2y. Because in this case, this is y. In this case, we consider this function. So this is exactly 2x over 2 times f of x, 2y. Of course, you can, 2 and 2 are cancelled. For this case, same. See? Minus 2. We can put a minus here, minus sign here. Minus and a minus is positive. This is exactly minus 2x. Wait a minute. I should put the minus at here. Here. And here, see? Automatically 2x minus 2 times minus square root of this one is exactly g of x. So at some neighborhood of this point, the function considered here is a minus sign here. There is a minus sign here. This is lowercase of g. Therefore, when we apply the implicit differentiation, yes, this procedure is called implicit differentiation. Implicit. Implicit differentiation means we don't need to solve y as a function of x explicitly. We just keep this in mind. This one is defined by this function implicitly. Then we can use chain rule to find y prime. Of course, in this result, usually this expression contains both x and y. Because if you, for same x, if give different values of y, maybe y is positive, maybe y is negative, means y may be defined as a function of x implicitly, a different portion of the curve. Okay. Then, at xy equals 3, 4, see, this is y. We don't need to solve this. This is the procedure here is called the implicit differentiation. We don't need to solve y in terms of x explicitly. We just keep in mind, here y is a function of x. That's enough. Then apply the chain rule. Okay. Same. If you want to find the slope of the curve at 3 minus 4, see? 3 minus 4, or automatically. Same x. X and x are the same, but different y. Because this expression involving y. So if y equals 4, automatically represent the slope here. If we use 3 minus 4, automatically this slope is positive. Okay. So this method is called the implicit differentiation. Yes, this means here. This is y. Y squared means x is mapped to y, then squared. Here you have to regard y, you have to regard. Keep in mind. You have to keep in mind. This equation defines the function y of x. Okay, keep this in mind. So y squared is not an independent variable, but this is exactly f. X mapped to y first, then squared the second. So differentiate this with respect to x. X is independent variable. Of course, this is 2x, but this is a composite function. Fx first, then squared. So we certainly use the power rule first, then differentiate the inner one. Outer one is square function. Inner one is the function y. Okay. Here y is not independent variable. If this is independent variable, then we treat this as a constant. This will be 0. But now y is a function of x, because when x is given, for example 3, we have y equals 4. 4 equals 3. 5 equals 0. Yes, here is chain rule. Yes, this is chain rule. Yes, you are right. From here to here, we use chain rule. Chain rule. Since x is mapped first to y, then squared. So y is a function of x. Okay. This equation has some function. For example, when x is given, then we can sub a y. If x change, then y changes too, according to this law, this condition. So we regard y as a function of x. But we don't need to write down the explicit form. We don't need to write down the explicit form. We don't need. We just keep in mind, y is a function of x defined by this equation. So differentiate this with respect to x means that differentiate this with respect to x. So here